Today we are going to show you the complete process of how to train an LTX 2.3 LoRA from scratch. What you are seeing right now is the Anne Hathaway LoRA I trained using AI Toolkit. I used this character LoRA to create a bunch of videos. I don't know if you guys noticed, but these videos look a little bit weird. So why does this happen? The reason lies in the training data. Usually due to copyright or other reasons, it is very hard for us to gather enough training videos. Plus, LTX 2.3 training data also requires audio, making data preparation even more difficult. Here, we used a full clip of Anne Hathaway giving a speech and cut it into 15 videos, each lasting 5 to 8 seconds. From my description, you can probably tell that this kind of training data is almost identical in terms of the character and the environment. Therefore, the trained LoRA will naturally have some issues. Next, we need to highlight some differences when training an LTX 2.3 LoRA. First, there are three types of LTX LoRAs. The first is called IC LoRA, the second is ID LoRA, and the third is what we call a standard LoRA. Today, we are training a standard LoRA or a character LoRA. When training an LTX 2.3 LoRA, we cannot use static images to train a video model like we do with WAN 2.2. There are many reasons for this, but the main one is that the model needs to generate not just video, but also audio. So we cannot use image training methods to train the video model. Because of this, the total number of training steps needs to be higher. Generally, we consider the training steps for LTX 2.3 to be about twice as many as WAN 2.2. Furthermore, training an LTX 2.3, LoRA requires a much stronger graphics card. We recommend using a 5090 GPU. This makes the overall speed much faster, and the training results will be much more ideal. To make it easier for you guys to execute the LTX LoRA training, we use two platforms. The first one is called Compshare. On there, we built an LTX LoRA training image for you. This platform provides all kinds of graphics card models, and I chose the 5090 here. At the same time, the system drive it provides is much larger. Additionally, it has an external network acceleration feature, which makes deploying images and downloading models much more convenient. Also, to verify the final training results, I uploaded the generated LoRA to Running Hub. In the CompUI space, Running Hub is a fantastic online workspace because whenever new models and technologies emerge, they are always the first to support them. This video mainly covers three parts. The first is model training, which includes dataset preparation, task creation and configuration, and the actual model training process. After training is complete, we will deploy the model to Running Hub to generate various videos, and then observe the pros and cons of generating a LoRA using this training method. Finally, we will briefly introduce the environment deployment. If anyone wants to install AI Toolkit locally on their own computer to train a LoRA, you can refer to my deployment process. Let's first look at a very important step, training dataset preparation. Actually, the safest way is to record various videos of yourself, ideally including audio, and turn them into your training corpus. Another method is to gather some clips from the internet. Here, I collected a full video of Anne Hathaway giving a speech. I cut it into 15 clips. The duration of each clip varies. The shortest is only 3 seconds, and the longest is close to 8 seconds. Next, let's talk about writing prompts. Generally, the prompt should be divided into two parts. The first part is the video description, and the second part is the audio description. The audio must be enclosed in quotation marks. The principles for writing the video part are the same as what we have taught you before. If you want the prompt to influence certain elements in the frame, you can write them into the prompt. For example, here, Anne Hathaway's default outfit and hairstyle are exactly as they appear in the video. I didn't give them any special description in the prompt. However, I did specify in the prompt that she is standing behind a microphone. Logically, if I don't mention a microphone in my prompt, it shouldn't appear in the video. Finally, let's talk about trigger words. You guys have probably trained a lot of large model LoRAs by now. You might have noticed that whether it is an image LoRA or a video LoRA, trigger words are actually not that important. If you need a sense of ritual, you can absolutely set a trigger word. Lastly, let's look at the organizational structure of the entire training dataset. We use numbers as the video file names from 1 to 15. Similarly, we generate a text file with the exact same name to store the corresponding prompt, just like what you are seeing right now. Once the dataset is ready, you can go into Compshare and find my LoRA training image through the link below. You can choose to use this image to deploy an instance. Below that, you can select a graphics card. We suggest choosing the 32GB 5090. Its 32 gigs of VRAM is basically enough, but its computing speed will be much faster, so the overall cost-performance ratio is slightly higher. We click Deploy Now, and the instance begins to initialize. Please note that the image I created for you has an auto start feature. Theoretically, you don't need to do any extra operations for it to start normally. Once you see the instance is up and running, copy its public IP address and append the port mine here is 8675, and then you can access the AI Toolkit. If this is your first time entering the system, it will prompt you for a password. The password I configured for you in the image is GANLOSS. Once you enter the system, if you only want to train an LTX 2.3 LoRA, you don't need to do any further setup. But if you also want to use this image to train other LoRAs, meaning you still need to download other models via Hugging Face, then it is best to add your Hugging Face token in the settings menu. Since I have already downloaded this model for you in advance, if you don't need to download new models, you can skip setting this token. Next, we will import the data we prepared earlier. Click on Dataset and create a new dataset. You can drag all the previously prepared videos and their corresponding prompts right into this dataset. At this point, the corresponding prompts will appear below the videos. You can check them one by one to see if there are any issues. Now, let's create a LoRA training task. You must pay attention here. Once a training task is created, it is not set in stone. That is to say, we will create a training task at the beginning, but during the subsequent training process, we will adjust various parameters of this task. In this training process, I roughly have two phases. The first phase is to quickly capture and display the character's features. The second phase is to process the details in the video much more meticulously. For these two phases, the parameters we use to configure the task are also different. All right, let's look at the first phase. I have already saved my previously executed training task inside our image so you can click and view it directly. But be aware, what you are seeing right now is the configuration for the second phase task. The first phase configuration is slightly different. First is the task name. You can write whatever you want for this. For model selection, you absolutely must choose 2.3. If you don't have the model, it will download it automatically. Additionally, you must select low VRAM because our 5090 GPU's VRAM is actually not quite enough. Also, you must check layers offload. If you don't select it, you might run into an out-of-memory error. For the quantization section, just select FP8 and leave it as default. We set the rank value to 32. This way, our final trained LoRA size will be nearly 600 megabytes. In the model saving settings, we choose to save a model every 250 steps, and we save a maximum of 4 models. For the training process configuration, we can basically just keep the defaults. The thing to note here is the number of training steps. I can put whatever I want for the first phase, because we will need to change it later. Just keep a basic rule in mind in the WAN 2.2 model. When we usually use static images to train a video model, we recommend around 2,500 to 3,000 steps. But since LTX 2.3 trains on video and includes audio, my personal recommendation is to double the WAN 2.2 steps, which means 5,000 to 6,000 steps. This is a pretty solid setup for the step count. Next is the timestamp type. Here we choose wait, but for this bias, we set it to high noise in the first phase. This makes the overall training speed much faster though. You have to note that the detail precision will be insufficient. During the second phase, we will change this to balance or even low noise. So it mainly focuses on optimization, making the generated video quality much higher. Another very important option is cache text embeddings. You must check this. This way, you don't need to use the text encoder to encode the prompt every single time. We can just cache them, and the training speed will be a bit faster. The dataset configuration is very simple. Just select the dataset I uploaded earlier. As for the resolution selection, you need to decide based on your graphics card. If it is a 5090, I recommend only checking 512 for the first phase. For the later phase, we can add 768. Also, you absolutely must check auto frame count to let it automatically calculate the frame length. This prevents the audio from abruptly cutting off, making the whole video much more natural. Finally, we have the intermediate sampling validation configuration. We still perform a sampling every 250 steps. Here, I chose the generated video resolution to be 960 by 544. Of course, you can choose 1280 by 720. Personally, I feel that 960 by 544 is enough to show the results. Now, pay attention to the design of the sampling prompts. We kept a total of 5 sampling prompts. The structure of the first 3 prompts is identical to our training data because we want to make sure it can reproduce the exact scenes from our training data set. For the 4th scene, we wrote a prompt to make the beauty hold a coffee cup, trying to set the whole environment inside a coffee shop. And the very last prompt is completely different. We used a highly complex prompt to describe an entirely different environment. And even the character's hairstyle and clothing are completely different from our training data. Our main goal is to see if, despite using highly consistent training data, we can still show different scenes by adjusting the prompt. During the training process, we do a sampling every 250 steps. You will notice that at the very beginning, both the character and the environment are totally random. From step 1000, the character gradually gets closer to our training data, though the last 2 prompts still show a huge amount of randomness. By step 2000, the character's basic state is well established. If we look at the generated video now, the character's body movements are already fantastic, but areas like the lips and teeth still look a bit blurry and lack detail. The reason is that the first phase only focuses on the high noise sampling part. Therefore, when we reached step 2300, I felt that the character's overall features were pretty much there, and we needed to fine-tune it. So I stopped the sampling and modified the configuration. We changed the bias to balance, and we also added the 768 resolution into our sampling resolutions. I kept this task configuration all the way to the final 5000 steps. You guys can take a look at the final generated results. In our specifically set scenes, the generated effect is fantastic. For the 4th prompt, the coffee cup appears, but she isn't sitting in a coffee shop. The scene is still quite similar to our training data. In the prompt, we also asked her to wear a hat, but this hat turned into hair instead. So we can see that the training data has a massive impact on the final generated results. For the last prompt, the character retained some of Anne Hathaway's features, and the overall environment and clothing basically matched the prompt. Even though we used identical training data that only showed one single scene, you will find that we can actually use prompts to display different scenes. Once training is complete, we download the final generated LoRA model and upload it to Running Hub. Then we use the LTX 2.3 workflow to verify it. We recommend you stick to a text-to-video workflow because if you use an image-to-video workflow, the whole verification process will be much more troublesome. Here, we still use the model provided by Kijai as the main model. The overall workflow hasn't changed. I simply added the LoRA model we just trained right after the main model and set its weight to 1. Next, we will run various tests on this LoRA. First, undeniably, the scenario it renders best is the speech scene we used during training. If we want to show other scenes, we can only achieve that through variations in the prompts. Due to the high consistency of the training data, you will notice that the various videos we get all carry the shadow of the training data to some extent. For example, here we generated a scene on a bus, but you will find that this bus scene looks a bit weird. During the entire testing process, we had single-person shots, two-person shots, and covered all kinds of resolutions. I think the overall generalization capability of this LoRA is still acceptable. If you guys can ensure that the characters and scenes in your training data are more diverse, I believe the overall effect will see a much bigger improvement. Finally, let's briefly go over the AI Toolkit installation. If you want to deploy AI Toolkit on your local computer, you can follow these steps. You can refer to its official GitHub page for the complete steps. I suggest you check the environment requirements before deploying. There are two main things here. One is the Python version, which should be greater than 3.10 and 3.12 is recommended. The other is an NVIDIA graphics card. Actually, there are some other environment requirements. Although not mentioned right there, it is written quite clearly below when installing PyTorch. The PyTorch version should be 2.9 and the CUDA version should be at least 12.8 or 13.0. Once this base environment is set up, the rest of the installation is pretty standard. First, we clone the entire code repository, then create a virtual environment and install PyTorch along with all the dependencies. I need to remind you here, if you want to do video training, you must install the FFmpeg library. Installing this on Ubuntu is quite simple. Just use apt install to get it done. Furthermore, the front end of AI Toolkit is developed using Node.js. So we also need to install Node here. You can go to the official Node.js website, select Linux as the platform, and here we choose to install it via NVM. Just copy these commands one by one and execute them to install. After that, you can use this command to start the AI Toolkit. We can also change the AI Toolkit password by configuring environment variables. If you have done Node.js development, you should be quite familiar with this method. In this video, we explained the LTX 2.3 LoRA training. Because the training data was quite specific, we cut a single long video into various clips. The data had a strong bias, resulting in slightly weaker generalization capabilities for the final model. Even though we can use different prompts to generate videos of different scenes, you will notice that the generated videos always carry a trace of the training video. Of course, what we hope you truly grasp is the method of model training. Training data can be continuously optimized to ultimately improve the LoRa's quality. Alright, that is all for today. What are you waiting for? Go try it out for yourselves. Follow me to become someone who truly understands AI.